So we'll have a look at the essential boot parameters for real-time performance. And the first one is the thread IRQs, which converts the hardware interrupts into threads, enabling priority control. Second one is the ISOL CPUs, which exclude specified CPUs from the scheduler. And those excluded CPUs can be used for RT tasks. Example, if you have, for example, a quad-core processor with 4 CPUs, and you want to isolate the CPU number 2 and 3 for your RT task, then you can do it using ISOL CPUs. Of course, here with a small e. Third one is the no hertz full, which disable the scheduler ticks on specific CPUs for fault isolation. For example, here, as I said, we want to isolate the CPU 2 and 3. And for that, if you are using ISOL CPUs for 2 and 3, we need also to use no hertz for the 2 and 3 CPUs. Then there is the RCU node CBS, which offloads the RCU callbacks from the RT CPUs. So here you deactivate the RCU callbacks on that isolated CPUs for the RT tasks. Then you have the RQ affinity, which assigns interrupts to specific cores. Here we need to avoid the RT cores, here meaning that you tunnel all of your interrupts to the other CPUs, meaning here the CPU 0 and 1. So we need to set ISOL CPU no hertz full, RCU node CBS for your CPUs you are going to use for your RT task, and IRQ affinity to the CPUs to the other CPUs. Then we have Intel P-state disable, which disables the Intel's dynamic frequency scaling. And then we have processor max C-state equal to 1, which restricts CPU sleep states to reduce latency. And the last one is the idle equal to pole, which keeps the CPUs active, which means we would not have any deep idle states. And this will also help our timing. Now next we'll move to the praxis, and we'll have a look at how we set those boot parameters in our real-time Linux. So first thing that we are going to do is to view our current boot parameters using cat proc and then cmd line, and this is my current command line. This is the boot image, the root, and here you have quiet. And then you can edit it using the following: sudo nano etc and then default group. And now you look for the group command line default, and here you can find something like quiet first, and then you can write your command line. But before that, let me check how many CPUs I have on my computer. You can check your number of CPU on your system using nproc. As you can see, I have 4 CPUs. Now I'll get back to editing my boot parameters, and as I said, here is my my default command line, and here you can add the things we learned before. So let's start with ISOL CPUs, equal to 213. Then no hertz full equal to 213. And then let's deactivate the RCOs. Go to 213. Then we have to activate the thread queues. Then idle is equal to poll. Then we have to route the interrupts to the other CPUs. So equal to 0, 1. And then we have to disable the Intel P state equal disable. And now we are done. And now we can exit. You can view it again to control that. And as you see, my command line persists. Now I can exit again. And that's it. Now you just update the group. And now you can reboot. After rebooting, you can check some of your boot parameters. First, we are going to validate the CPU isolation. So type cat sys devices system CPU and then isolated. And you can see Linux tells us that the third and the fourth CPU are isolated. You can also check the tickless operation. So here the same command line, but instead of isolated you type no hertz full, and you can see that the third and the fourth CPU also have tickless operation. And in this way we validated that our boot parameters are correct and they are persisting. And with that I come to the end of this lecture, and see you in the next one.